We continue. This is question 13. This is a question under second theorem. In the diagram below, A, B, C, and D, A, B, C, D are points on the circumference of a circle centered O. Angle DAT, DAT is 40 degrees. It is 40 degrees. Angle BDC, BDC is 30 degrees, and AT is a tangent to the circle at A. AT is a tangent to the circle at A. So, before we get into details, let us look at the properties of a circle. This topic is under circle theorem. Circle theorem. Okay, so now let's assume this is our center. This is our center. So whenever the distance around the circle, we call it the circumference. You can also say the perimeter of a circle, right? Meaning the distance around the circle. Then we have the center. Let's assume we have this line passing through the center. It is called a diameter. Let's assume we have another one passing through the center, but it's not connecting to the other end of the circumference. So a diameter cuts the circle into two equal parts. You see? So we have this line from the center touching the circumference. We call it radius. So it's like we have a radius. Even this one is a radius because it is also touching the circumference, right? So now it's like even this one also is a radius. So if you connect a radius, two radii, plural form for radius is radii. Two radii, when they are connected in one line, they make a straight line and it makes a diameter. So a diameter has got two radii. You see, from here up to here, radius, from here up to there, radius. So this part bounded by the two radii, it is called sector. So as you can see, this is a minor sector. The rest up to there, here, it is a major sector. You see that? So now, what about the part from here alone up to here, where the sector is? It is called an arc. So this is the minor arc, and the rest from here up to the other way around, it is called a major arc. Okay, so now remember we had a diameter. We had a diameter cutting the circle into two equal parts. Now let us try to draw another line. This line, it won't cut the circle into two equal parts, but it will pass the way the diameter passed, like touching the both ends of a circumference. So this line, it is a chord. This line is a chord, right? It is a chord. Now, what will be the part bounded by the chord? This part is called segment. So as you can see, it's a minor segment, and the rest up to there, it is the major what? Segment. So take note. So we read the question again. In the diagram below, A, B, C, and D are points on the circumference, A, B, C, D, of a circle. Center is at O. DAT, angle DAT is 40 degrees, and angle BDC is 30 degrees, and AT is a tangent to the circle at A. So now take note that we can begin to feel some angles here before we even read further what they want us to do. We can begin to feel some angles. We fill in some angles. So now, have you seen this angle 30? There's also angle 30 somewhere. Have you seen this angle 30? It was formed by the lines coming from CB, right? From CB, look at this. From CB, it went until it formed an angle. Now, come from the same CB and go the other way around. It will come at A, right? It will come at A. So it means angle 30 and this angle here, angle BCD and angle BAC, because they must come from the same points, which is a chord. This is a chord. Remember the properties? So even here, it is a 30 degrees. Why is it a 30 degrees? Because they are lying the same segment. If BC is our chord, then this one is the major segment. So angles which lie in the same segment are equal. So even angle BAC or CAB is 30 degrees, right? Before we read the questions, we can fix some angles here. So now, look at this tangent. Whenever there's a tangent and there's a line coming from the center touching, just know that that angle is 90 degrees. The mid here forms 90 degrees. They form 90 degrees at the point of contact. So if this is 40, what about here? So you do 90 minus 40, you get 50. So here's 50. You see? The reason being, when a radius touches the tangent at the point of contact, it forms 90. So 50 plus 4, you see, plus 40, sorry, it gives you 90 degrees, right? Apart from that, this is a diameter. A diameter will always pass through the center, which is center O, and it makes a semicircle. There's a semicircle, a circle there, half circle there, half circle here. So there's a property which says angles formed in the semicircle is a right angle. The angle formed in a semicircle is a right angle. So what they are trying to say is this angle from here up to there, this is 90 degrees. This is 90 degrees, right? Look at that. So we have done something here. Let's maybe read the questions now. Calculate angle CBD. So angle CBD where C, B, D, the angle here, the angle there, angle CBD, CBD here. Now look at this triangle. This is a triangle. We have 90 here, we have 30. So angles in a triangle add up to 180 degrees. So you add the available angles and subtract from 180 to get CBD. So you add 90 plus 30, you get 120 degrees. Now since angles in a triangle add up to 180, you therefore subtract 180 minus 120 degrees. So 0 minus 0, 0, 8 minus 2, 6, 0, 1 minus 1, 0. So the angle at B is 60 degrees, which is CBD. So this is the answer, 60 degrees, CBD. It is 60 degrees, right? So now, next, find angle BAC. 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 It is 30. We already found it. BAC. It is 30 degrees because this angle is lying the same segment with this 30. They are all coming from BC, point BC, which is our chord. So we already found it, remember, at first. So question B, BAC is 30 degrees because they lie in the same segment with this angle. Now C, angle AOB, angle AOB, AOB, this one. This is AOB, AOB, this angle. Now, first of all, for us to know this angle, we must know the other angle here. We must know this angle here. So that when we know this angle, we know this is a straight line. We simply do 180 because angles on a straight line give supplementary. So you simply subtract the one that we're going to have here minus 180 to get this one. Then it will be easy for us. So now let's do it. Let us do it. So there are a lot of ways on how you're supposed to find this angle. This angle, or this angle, right? So now let us do this. So for us to know this angle, we have to know, remember, this one is an isosceles triangle. This is O, this is D, this is A. At A, we already found a 50 degrees. So in an isosceles triangle, these are the same, meaning O to D, O to A, they're the same. Yes, they are all radii, radius. So if here is 50, even here is 50 degrees, right? So for you to find the angle here, which is this one, you simply add 50 plus 50, which is 100. Then you do 180 minus 100 degrees because angles in a triangle add up to 180. So 0 minus 0, 1, 80 minus 0, 8, 1 minus 1, 0. So just say 80. Meaning here it is 80 degrees. And here it is what? 50. Remember the 50 here? 50 degrees. Now, since this is a straight line, and we know the way this line has been formed, it is like this. This is BD. O is here. So if this is 80, what about here? You know, this one is coming from air. What about here? So angles on a straight line should give you 180, or we say they are supplementary. So since it is 80, supplementary means 180, right? So you do 180 minus 80 degrees. 0 minus 0, 8 minus 8, 0, 1 minus 1, 1 minus 0, here you can put a 0, it is 100 degrees. So it means AOB is 100 degrees. AOB is 100 degrees. This angle here, it is 100 degrees, right? This is what you are supposed to do. So it is as easy as that. So there is another way on how you can find this angle. Hope you'll be able to see. But there's another way on how you can find this angle. Apart from using this triangle, you can use just this one. So you remember that this triangle, this is a semicircle, right? Because there was a diameter which was cutting the circle into two equal parts, right? So angles in a semicircle which are formed here is 90 degrees, meaning the whole lot of this up to here is 90. We are supposed to add, excluding 40, right? But this one A, this 50 and this 30, and this one in between must give us 90. So if this is 50, this is 30, this is 80, it means the smaller one is what? Is 10 degrees. The smaller one is 10. So you have 50, 10, 30, 90. Just like here also it is 90. Why? Because these are semicircles, half circles, right? Now, still, this one is an isosceles triangle. This is O, this is B, this is A. Now, this is 30. Have you seen line OA? You see, there's 10 and 30 degrees. So we have 40 here. In an isosceles triangle, these two sides are equal. It's a radius OA, OB is also a radius, so they are equal. So we call it isosceles triangle, right? So if this is 40 degrees, even here is 40 degrees. What about this angle? What about this angle which is here? So angles in a triangle add up to 180. So you do 40 plus 40, it is 80 degrees. Then you do 180 minus the 80 degrees. You're going to have 100. So here is 100 degrees, just like we found earlier by using that triangle, right? So this is what you're supposed to do. So angle AOB is 100 degrees like we found earlier.